My name is Abeykoon A.M.Y.V.B. My IT number is IT21197246. And for this project, I have trained a logistic regression model to identify fraudulent transactions in a credit card fraud detection dataset. Now, to begin with, I have imported the necessary packages to actually do this. And then I've done some steps to visualize the data to identify what are the features that we're working with, and to show what are the null data that we have, and if any of it needs to be removed, what data types we're working with, and we can actually I also put it into a histogram to check how much uh, null data is present in the columns, which there were none, as well as I did some other visualization to identify the class distribution in the dataset to identify which classes were fraudulent and which were not, and then to see how that was actually skewed, which is a lot, and then a numeric distribution to check if we need to actually scale any of the extra data, because these are the float values. I checked these, and the only ones that needed to be scaled were these. So I used the standard scaler, which we'll get to later. And yeah, I did some further checking to see the min maxes and the standard deviation, etc. And then the correlation analysis, which is important to see just which values. I actually did it to see if we need to do any more feature scaling, and if we needed to remove any features, because I wanted to check if there was any correlation between the features, which there was almost none, mostly none. And I checked the target correlation as well. And then I split the data into 80-20%, 80-20, so 80% training, 20% testing. And I applied a standard scaler to the dataset to, again, scale the time and the amount. And then I tested around with SMORT to identify to see what are the optimal SMORT values, which I have written in a different document, but we'll get to that. And to test the best SMORT sampling that we can get, and these are the best parameters that I could find. And then I moved on to hyperparameter tuning for my model to identify the best parameters for the model. So upon using grid search to actually hyperparameter tune this, I came up with these parameters. However, personal testing found that these parameters that I find here using LBFGS, which is a very long word and I can't say it in one go, were the better models actually training. I got a better recall and precision. I will better recall when using these parameters. So that's what I trained, and the rest of the evaluation metrics you will see are from that LBGSF FS. And then so for model evaluation, so not this. I used threshold tuning, so threshold sweeping, to find the best thresholds, which would give me a mix between a good amount of precision, but mostly to get a high recall value without sacrificing too much on precision. So that overall gives me a good F1 score as well. But these are trained on F1 score, but what I was hoping for was a high recall. So you can see in the threshold metrics here that about 0.99 is actually where we're going to get the best overlapping precision recall and F1. So that's what I went with when it came down to the final evaluation. I went with a metric of 0.99 threshold, as you can see here. Right. So yeah, and you can see in the confusion metric, I've just laid down visually what kind of results that I have gotten, and the ROC curve as well, and the precision recall curve, which again shows that at about 0.84 recall, which is what we have, as you can see here, at about 0.84 recall is where you get the best precision, which is what we got. And thank you. That's the end.
I am M.D.A Sooriyaarachchi. My IT number is IT21173790. In this project, I am using SD boot algorithm to detect fraudulent credit card transaction. The goal is to train model that can be accurately identify fraudulent transaction from the real world data for real world credit card transaction. First, I install and import necessary libraries, including XGBoot for modeling, pandas and NumPy for data manipulation, Seaborn, and Matplotlib for visualization, and skitlearn for model evaluation. And next, I load the credit card fraudulent detection dataset using pandas framework. framework. And here I check the shape of the dataset uh, dataset to understand the number of rows and columns. There are 31 columns in the dataset. Uh, Using info function, I get quick overview of the dataset, including the type of the features and whether any null values are present. There are not null values in the dataset. Also, I print the first 5 rows in the dataset using head function. Uh, Understand what the data looks like, and especially checking the features like time and amount and the anonymous features V1 to V28. Next, I check for missing values to ensure that dataset is clean and ready for pre-processing. Uh, Next section is data pre-processing, and I check the duplicate rows and remove the prevent the model from learning redundant information. Uh, Next, I split the dataset into the feature X and target Y where class is the target variable indicate for or not. Next, I split the dataset into the training and testing set using 80% and 20% split and satisfy on the target variable to create the plot ratios. If Next I check if there are any missing values, and I would fill them with the mean value. In this case, the dataset had no missing values. Next I check again. I check the shapes of the training and testing set of the shapes of the confirm the splits. Next I convert the training and testing set into the SDBoot optimized format called D matrix. Set the model parameters like binary distribution tasks and trees, the depth of the trees and learning rate and loss function and state for the parallel computation. Uh, SD boost model 100 boosting rounds. I set to 100 boosting rounds. Next, after training, I make prediction on the test data set and compare them with actual values and assess model performance. This is the training accuracy 0.9. This is a testing accuracy 0.9. This is the actual and predicted values comparison. Uh, Next, I calculate and print the model accuracy, which shows overall percentage of the correctly predicted transaction. Its accuracy is 0.99. Next one, I create confusion matrix to visualize the true positive and true negative, false positive and false negatives. Now I calculate additionally evaluation metrics like vision, recall, and F1 score. There are critical for imbalanced dataset like for detection, and where simplify high accuracy is not enough. Finally, I plot the ROC curve and calculate the ROC and AUC score, and higher AOC value indicate that better performance in distinguish between fraud and non-fraud transaction. Thank you.
And this is the libraries that are required for our project, and this is the data dataset part, and the represent whether the transaction was fraudulent or not. The majority of the data consists of legitimate transactions, with fraudulent transaction being extremely rare. Here we check the class distributions of the dataset as expressed the fraud cases are very few compared to the legitimate transactions. And this is data pre-processing part. In this step, we prepare the data for model training. We separate the feature from target variable, which is the class column. After that, we split the data into training and testing set using straight sampling, maintain the original class distribution in both sets. This ensures that both our training and testing dataset represent the same class imbalance. And this section is initialization and training the SVM model. Uh, and now we initialize the linear SVC model. We use class weight imbalance parameter to handle the class imbalance. This tells the model pay more attention to the binary class that program class function. I also set dual false for fast computation and max also to ensure the model coverage. And then we train the model on the scale training data, and we also track the time mistake to train the model, which is about 2.7. Training time can vary depending on the size of the data set and the complexity of the model. After the training, we save model using WG for later use, so we don't need to train again. And this is model evaluation part. We evaluate the model using precision recall curve and AUPRC to assess how well it handles imbalanced data. The recall for fraud is high, but precision is low, indicating false positive. The conversion metrics also show how many frauds and legitimate transactions are correctly or incorrectly predicted. And I summarize the key metrics of PRC, recall, and precision for fraud detection. The model performed well in detecting fraud but could improve in precision. And this is charts. It's That's my part.
Hi, my name is M.G.S.D. Kumara, and today I will be demonstrating how we can implement the random forest algorithm to detect fraudulent credit card transaction using the dataset from real-world financial scenario. So we start by loading the dataset, which contain the various features such as transaction time, amount, and other anonymous variables. The target variable is classes where one represent fraudulent transaction and zero represent legitimate ones. So the to begin with, we perform some basic preprocessing. We using algorithm scaling and the amount column to reduce the column and the reduce the skewness, and we drop the original amount column since the trans log amount is a better feature for the models. We then split the dataset into train, test, and validation and tested. This ensures that we can evaluate the model performance on unseen data later. Next, since flood is an extremely rare event in this dataset, we apply the S.M.D.A technique, which generate a synthetic sample of the minority classes based the dataset. This is crucial because the model training on imbalanced data may be based toward the predicting the majority class. So then we define the preprocessing pipeline where we scale numeric future likes times and log amount using the standard scale. After that, we define the random forest classifier with hyperameter avoiding overfitting, such as limiting the depth of tree and controlling the number of level. We perform hyperameter optimization using random search CV, which help find the best parameter for the classified short amount of time. We do this by trying different values of parameter like the number of tree, n estimator, and the maximum depth of tree max depth likewise. Once the model is trained, we evaluate it on the validation sets. We calculate various metrics such as F1 score, ROC, AUC, and percent recall AUC. These metrics give us a detailed picture of how well the model is performing actually in detecting fraud. For example, random forest model achieved F1 score 0.82, which indicate the good balance between precision and recall. So, and in summary, random forest is effective and robust algorithm for detection, especially when they combine with technique like SMOTI for balance the dataset type parameter optimization, fine tune the models. Thank you.